In math, you generally learn about x and y. Eventually you learn x, y, z, and this is known as the Cartesian coordinate system. But there are many others. And eventually maybe I'll come into the generalized, but for right now there's the spherical, and that's assuming that you're working with a sphere or something along the line of that. There's also cylindrical. These are for 3D coordinate systems. Cylinder is like, like a can of soda. Spherical is like a ball, or like Earth. And in order to make this sort of change, you have to make some sort of substitutions. For spherical, x is equal to rho sine of phi cosine theta. Y is equal to rho sine of phi sine of theta. And z is equal to rho cosine of phi. Cylindrical is a little bit different. X is equal to r cosine theta. Y is equal to r sine of theta. And z is equal to z. It's almost like a circle that's been extended into the third dimension, but it just extends one way. Spherical is like a circle in every single direction, kind of. So when you square all of these terms, you get x squared plus y squared plus z squared is equal to rho squared. And for cylindrical, x squared plus y squared is equal to r squared. When you change coordinate systems, it is a little bit tricky. In Cartesian coordinates, you have x unit, y unit, z unit, or if you're a mathematician, you'll have I unit, y unit, that's not what I meant to do. I mean, j unit and k unit. These are vectors in these directions, and they are always constant, so you don't need to worry about anything like that. You basically just start like, oh well, it's always pointing in this orthogonal basis. They're always length 1 and they don't change. In new coordinate systems, you're going to have new unit vectors. For spherical, for instance, you're going to have rho hat, phi hat, and theta hat, just based on the variables that are in this coordinate system. In cylindrical, you're going to have r hat and theta hat and z hat. For cylindrical coordinates, remember the substitution. R squared is equal to x squared plus y squared. So r is equal to the square root of x squared plus y squared. X is equal to r cosine phi. Y is equal to r sine of phi. With z is equal to z. R unit is equal to r over r. this is going to be x unit plus y unit all over r. And this is going to be x unit cosine phi plus y unit sine of phi. So as you can see, our unit is not constant. It is changing based on the location of phi. The next one would be what is phi unit, and for this we can do z unit cross r unit, and we can do this because phi unit is going to be orthogonal to both z unit and r unit. And when we do this, we have z unit cross cosine phi x unit plus sine of phi y unit. So these cosine phi and sine of phi, these are constants that can be pulled out of the cross product. So cosine phi z unit cross x unit is going to be cosine phi of y unit, and then z unit cross y unit is going to be minus sine of phi x unit. And this is what our phi unit is, or phi hat, I should say. And then z unit is obviously just going to be z unit. So phi hat here is obviously not constant either. It is changing based on the angle of where it is. Okay. Oh. Spherical now is an entirely different beast. We have x is equal to r sine theta cosine phi, y is equal to r sine theta sine phi, and z is equal to r cosine theta. And we want to convert from xyz to r theta phi. So one thing to keep in mind is spherical is a 3-dimension, and it's for spherical objects. R is the radial distance, so how far it is from the center. Theta is the angle from the z-axis, known as the polar angle, and then phi is this angle, and it is known as the azimuthal angle. So it is the angle from the x-axis, and the polar axis is from the z-axis. And as we move around the sphere or the surface, or for whatever reason why we are using this coordinate system, but as we move around, these unit vectors are going to be changing. They are not constant, just as in cylindrical coordinates. For our unit, we can say r over r magnitude, just as before, and xx unit plus yy unit plus z unit divided by r, which would be the square root of x squared plus y squared plus z squared. And this is a lot of tedious algebra that the listener, the viewer, you can do. You just plug in these values of x, y, and z into here, and then you solve for or isolate x unit, y hat, x hat, y hat, z hat, and you should end up with x hat sine theta cosine phi. You should end up with x unit sine theta cosine phi plus y unit sine theta sine phi plus z unit cosine theta. This looks a lot like the substitution we use to make cylindrical coordinates, except without r in there. And this is known as r hat. Phi hat, we can take r unit and differentiate this with respect to phi hat, or phi. And once we differentiate this, we get phi hat is equal to x unit times sine theta plus the derivative, or times the derivative of cosine phi, which is minus sine of phi, and then plus y unit of sine theta, and this is going to be cosine phi. Z unit is going to be 0 because there is no phi term. So then phi unit is going to be x unit times sine theta sine phi, put a minus sign there, plus y unit sine theta cosine phi. But wait, I made a mistake. This is not actually the unit vector, this is just the phi vector in the phi direction. To make this a unit vector, let's factor out sine of theta from the x and the y units. So it's going to be minus sine phi x unit plus cosine phi y unit. Oops, not theta, phi unit, phi vector, sorry. And this is actually the magnitude of this vector. And what we can do now is divide by sine of theta to get phi hat is equal to and the reason why this is because this is, no, I keep writing theta. That's not what I meant to do. Because this is going to be phi hat divided by the magnitude. This is the magnitude of this vector, and this is why this becomes phi hat. And it's minus sine of phi x unit plus cosine of phi y unit. That just leaves theta unit, or theta hat. To get theta hat, we can take phi hat and cross product with r unit. And this is a little tedious too. Let's write phi unit cosine phi y unit minus sine phi x unit cross sine theta cosine phi x unit plus sine theta sine phi y unit plus cosine theta z unit. So we're crossing these two vectors. This can be done step by step. It can also be done with a minus b cross, let's call it w, is equal to a cross w minus b cross w. And when all is said and done, theta hat is equal to cosine theta cosine phi x unit plus cosine theta sine of phi y unit minus sine theta z unit. We can also invert these and find the Cartesian coordinates in terms of the cylindrical or spherical unit vectors, but I may or may not do that. I'm not sure yet. It is a lot of tedious algebra, and I want to just make this as simple as I can.